Okay, everyone. Your physics teacher again. So this one is lesson 2. There's a chapter 2 for the physics from 5, electricity. So I think the student for the 5 science one you learned already. But I just want to recall back for the 5 science 3. This one is a new topic lah. So today morning I call you to download the tutorial. I send you the lesson. So you please print out. Then I want to explain about the 2.1. Okay, this one is a tutorial and also the lesson 2.1. Okay, the topic is electric field and also the charge. So for this one topic, I will introduce about what is the charge. Okay, number 2 is what is the electric field, and number 3, what is the current. Okay, now we're going to see the first part. Okay, first part follow the notes. The first diagram that show you the atom. Okay, now we want to see the structure of the atom. Okay, atom. Inside the atom, we got one of the small part, we call it the nucleus. Is it nucleus? Okay, center of the atom. Okay, we say about center of the atom. Okay, they got proton, then also they got the neutron. Okay, sorry about the nucleus, you forget about that. The nucleus is biology. Okay, for the atom, inside we got the proton and also the neutron. Okay, at the center. So the whole mass is from the center of the atom. Okay, now surrounding the orbit, they got the electron. Okay, so from here they say the positive charge is a proton. Okay, then after that the negative charge is the electron surrounded. Okay, and the center we got one of the neutron. Neutron is a neutral charge. They don't have any charge. Okay, so from here follow the notes. First one, there are two kinds of the charge we call negative and also positive charge. Okay, like charge. Like charge means, okay, two positive charge, when they put together, okay, this one we got like charge, so you find it, they will repel each other because the charge is the same, so they will repel to each other. If you find there is unlike charge, unlike positive and negative, so that means they will attract to each other. So this one we call like charge and also unlike charge. Okay, and the object become negatively charged when it's gain access of the electron. How come we call it there's a negative charge? Because the atom, they gain more the negative charge, more than proton. So we call it there's a we call it as a negatively charged of the atom. So number 2, we finish about this one, positive and negative charge. Then we see the similarity when the object has the same electron removed, the object also become positive charge. Example for the atom, if the negative charge become less, there's a more proton charge, so that means we call it there's a positive charge of the atom. Okay, so this one just want to introduce the positive charge and also negative charge. Okay, like charge, they will repel, unlike charge, they will attract. Okay, now we're going to see the introduction for the charge. Okay, charge. First one, the symbol is Q. We're using the capital Q is a symbol for the charge. Number 2 is a unit. Unit of the charge we're using capital C. Okay, this one capital C, not the charge. Capital C is coulomb. Okay, 1 coulomb, 2 coulomb. Okay, here we got explain for you. C is coulomb. Okay, after that the charge of the electron. Charge of the electron is a fixed. You don't need to memorize. For the exam they will show you. Okay, there's a 1.6 times 10 power of negative 19 coulomb. Okay, so this one is a electron charge. Okay, then we're going to see the electron charge finish. We're going to see the current. Okay, current, this one is a base unit. Remember, we learned about 5 base unit. Time, mass, temperature. Then after that we got length. Okay, last one is the current. Current is Form 5 we need to learn. Okay, current, the symbol is I. Okay, we're using I. Then let's see the definition. Rate of flow of charge. Remember I told you rate of. What's the meaning of rate of? Rate of means the formula must be over time taken. So from here they say rate of flow of charge. So the charge at the top, then the time taken is below. So from here you find the formula is I equal Q over T. I equal Q is a charge over the time taken. So from here the unit for current we can write about ampere. You also can write about coulomb per second. So this one we call current. Okay, next we got another formula. There's a how to calculate the total charge, okay, for one of the electron. Or say how we want to calculate one charge is inside, got how many electron. Okay, now we go and see the formula here. Q equal NE. Q equal NE. So Q stands for total charge. How many charge? Okay, N means number of electron. Inside got how many number of electron? Last one, electron means this one, electron. Okay, inside one electron they got this one charge. Okay, now the question will give you total charge. They give you one of the number of the charge, then they ask you inside this one charge got how many electron. So you need to using the formula Q equal NE, then you find the answer for the N. N is the number, so we don't have any unit for N. Okay, so this one I explained already. So just got two formula. First one, I equal Q over T. Then the next one is Q equal NE. Both formula we can use together because both also got Q. Okay, now we're going to see the example one. We try the example one. Okay, I show you the question first. Okay, for the student, you know they download. So please, so I show you the question. Okay, you see the question. Okay, so I read it. A charge of 600 coulomb, they flow through the metal conductor in every 5 minutes. Then what is the electric current in the conductor? Okay, now I go and clear the board. I rewrite the question. Okay, now we're going to see the question number one. The charge is a 600 coulomb. Q equal. Second one, time taken is a 5 minutes. Okay, 5 minutes. Normally we want to using the minute. We want to using the SI unit. So you need to convert 5 multiplied with 60. Okay, it becomes 300 seconds. Okay, the next one they want to find is what is the electric current. I equal is how many? So from here we just apply two formula what we learned just now, is it? One is I equal Q over T. Another one is a Q equal NE. So apply the first one, we're going to find the current. So I equal Q is 600 over 300. Okay, so I find it, my answer is a 2 ampere. So we just finish the first one. Okay, let's see the second one. Second one, I zoom again. An electric current of 3.2 milliampere flow through the bulb for 4 minutes. Okay, now the charge of the electron is given. Okay, first one they want you to determine A, electric charge. Okay, number two, number of electron. So from here we write the info first. This one is question number one. Now it's question number two. Okay, I move here. Okay, question number two, they're talking about the current. They give you the I equal 3.2 milliampere. So 3.2 milli is times 10 power negative 3 ampere. Okay, the next info is time taken. 4 minutes. 4 times 60, 240 seconds. Okay, then okay, no more already. They give you electron. Electron is 1.6 times 10 power negative 19. Okay, now you're going to see the first question, electric charge. That means you want to find Q. Okay, you want to find the Q. Okay, we got I, we can using this formula. It's straightforward to find the Q. So Q equal IT. Okay, you take the I here, multiply with the T. So I get it, the answer is 0.768 coulomb. Okay, so this one is the answer for the A when they ask about charge is how many. Okay, the next question is the number of electron. How many number of electron inside this all charge? So from here we need to apply the second formula. Second formula, Q equal NE. So Q is, okay, we write the Q is 0.768. Then the number we do know. Then the electron we know. Electron is 1.6 times 10 power negative 19. Okay, so from here you need to find out what is N. That means n is the number, no unit. So from here I get the answer is 4.8 times 10 power of 18. Okay, this one is the number of electron, I get it. Okay, number of the electron, I get it. So from here, this one is a 2 answer for 2 example question. Okay, please refer that. Okay, so I need to go the following. There's an experiment, relationship between the electric charge and also current. Okay. Okay, now you're going to see the experiment. We can say there's not experiment, just one of the activity. They want to find the relationship between the electric charge and also the current. How come the current, if got charge is increased, how about the current? Okay, so from here, they got hypothesis. The current increases, that means the charge also increase. Okay, so from here where we go to manipulate variable and responding. Okay, follow your notes. The aim, you want to investigate relationship. That means the charge relationship with the current. Okay, normally we know lah, when the charge more, the current should be higher. Okay, we control is the charge. How to make the charge become more and less? Okay, first one we're using the Wonder Graph. Wonder Graph. Okay, if I'm not mistaken, I show you during the class for 5 science 1 student. Okay, then after that, you can see the diagram through here. Okay, Wonder Graph. After that, we got 2 plate. Okay, Wonder Graph always they produce the charge is a positive charge, just like one of the ball. Okay, it produce is a positive charge. This one is a bell. The bell they keep rolling, so they produce a positive charge. Okay, I can show you the diagram. Okay, this one is an example of the Wonder Graph. Okay, remember the Mr. Bean, they go and play one, they go and touch, after that the hair all up already. This one is a Wonder Graph. Okay, when you just on, you find it, they will generate the positive charge on the top. Okay, on the top they will generate positive charge. When they generate positive charge, that means any object, when you got electron, they should be attracted. Example, you see this part. This one want to hit. Okay, you don't need to hit, like just closer only, closer with the dome. So you find it, they will attract the electron. When they attract the electron, that means you produce the spark. So this one we want to test. How about the charge related with the current? Okay, so this one is a diagram for the Wonder Graph. Then this one is how they function. Okay, center is a belt. The belt is moving, then they generate the positive charge. Okay, remember Wonder Graph just generate positive charge, no electron. Okay, now we go. Okay, the activity again. Okay, so from here they say by using the meter rule, the distance between the 2 plates. Okay, so Wonder Graph, positive Z, they join with the 2 plates. Okay, another plate. Okay, we join by the emitter, join with the emitter and also the ground. Ground is an electron. Okay, so from here you find it. When I just on the Wonder Graph, there will be positive charge. That means this plate will become positive charge. Okay, so this one plate they got mixed lah, they got positive and also negative. Okay, so from here when I just on, okay, by using the meter rule, distance between 2 plates, we adjust first. Okay, example, you want to put 10 cm, put 10 cm first. Okay, now when I just on, the motor Wonder Graph is turned on for a few minutes because you need to generate the charge. You need to wait for a few minutes. Then the ping pong will touch the blade. Now when I just generate the positive charge, now the ping pong ball will move because the charge will be attracted. Okay, example before that, this one is a neutral one. Neutral, that means you got positive, you got negative. When I full charge with the positive at the plate here, they will attract. Any electron, they also will be attracted. So the ping pong ball will attract here. Okay, when I just attract to this part, okay, then now the ping pong ball, they will receive all the positive. All the positive will go to the ping pong ball. Okay, now what happens for the ping pong ball? Ping pong ball become all positive charge. When it become all positive charge, what happens? I told you, like charge, they will repel. So from here, the light charge, ping pong ball and the plate, they will repel to each other. Now ping pong ball, they will attract to another side. Because you all positive already. Here got negative what? Because you earth. So now another plate will attract the ping pong ball, will come back to another side. When they join with this side, what happens for ammeter? Ammeter sure will deflected. Okay? The needle will deflected. So when the needle just refracted, that means you can read what is the reading for the microammeter current. Okay, excuse me. Okay, so now number 3. The ping pong ball is touched to the metal plate. Then the reading of the microammeter is recorded. When I just go to the ammeter, what's the reading? Then you record. Okay, now this one is a one set. So I on, and the ping pong ball touch until they touch to the electron plate. Then I read what's the ammeter. So this one is a one set finish. So repeated, how you repeat? So I make the distance increasing. Make the X. That means this one 10 cm. I repeated minimum 4 set. Then you go to 15 or then 20, maybe too large. Maybe you say 10, I make it become 12 cm, and 14 cm, 16 cm. So after that, you see what's the reading for the ammeter. So we find it, we don't need to do experiment, we know the hypothesis. When you go further the distance, the charge become less already. When the charge become less, so the current also become lesser. So this one is one activity they want to prove. How about the charge and current, what's the relationship? Okay, so from here they show you the experiment repeater with the different distance between the two plates. Okay, then this one is a tablet data. Okay, two axes. One is for the metal plate, there's an X cm. Then the responding is a current. Then this one is a plot graph. How to analyzing the graph. Okay, this was one activity. Now we need to go is the second part. That's the electric field. Okay, the charge. How we draw the charge. Okay. Okay, electric field. Okay, electric field. The first one we need to know the definition. Every term you need to know the definition. Okay, electric field example, this one is a charge. Positive charge, then this one is a negative charge. Okay, surrounding the charge we got area. You see, this one we call area. Area surrounding the charge. This area we call electric field. Field is what? Padang. So from here surrounded the charge we got area. This area we call electric field. Okay, now what is the actual definition? Okay, actual definition. Okay, right here. Okay, the actual definition is the region where the charge experiences an electric force. Okay, so that means the region, the area. So this one positive, and I mean this area. So I draw first. This one we call positive charge. Surrounded with the positive charge, we got arrow in red. This arrow suppose we call it there's a electric force. You cannot see, but we can feel. When you want to attract, they can move using the method. Okay, using the positive charge and positive charge put together, they will repel. This one is the thing that's called force, repulsion force. Okay, so from here, this one is a region. That means this whole area lah. This whole area we call it as an electric field. So remember the definition, the region, okay, where the charge, this one charge, they experience what? Electric force. So we call it electric field. Okay, now electric field can be represented by the arrow line. Okay, we call it electric field line. This one is the electric field line. Okay, electric field is strongest. How we say electric field is strongest? When the line, all the electric field line become more. When they draw more, mean this one is a strong electron charge. Okay, strong charge. Okay, now the electric field line, they never cross. When you draw, we cannot cross over. Okay, example positive you draw. Okay, you cannot say, okay, this one also positive. We cannot cross, this one is wrong. You must draw one by one for the charge, the electric field line. Okay, now they start on the positive charge and end of the negative charge. What means of start positive and end negative? Okay, this one is a positive. Okay, so how you draw the charge? How you draw the electric field? Electric field means you draw the center first. Okay, this one is a normal. So the arrow is up from the positive. Okay, if I draw another negative, another electron charge. So electron, this one. So electron. Okay, also same for electric field. Okay, the arrow is go in. Now, this one is an electric field for negative charge. So that's why they said it. The electric field line of the force, there's a start from the positive, start from positive and in the negative. So this one is a personal charge, positive and negative charge. Electric field line of the force is a vector quantity. This or is a vector quantity. Why? Because both got direction. You draw in and out, that one is the direction. So charge is a vector quantities. Okay, now we're going to see an example with how to draw first. Okay, let's see here. I draw one example is when two charges they move, put together. Okay, positive and negative. Okay, when the two charges put together, that one is a like charge. They attract each other. So attract each other center, that means they must got the line. You cannot empty. Okay, how we draw? First one, we draw the field line straight first at the center. Okay, both sides also got. Next, up and down, up and down. Okay, center must full because you are attract each other. So this one we draw curve. Cannot cross each other. So we never cross. The line cannot touch. So from here the rest, we draw lah. Okay, the rest we just draw. Okay, you want to draw curve a little bit, come here. So go here. Okay, you must show they want to attract. So from here we find it. The line, okay, the line is finished. Okay, I find it as attract each other. So you need to label the arrow. Remember, out from positive, then in to the negative. So out, or is out from the positive. Okay, then out. Okay, how about the negative? In. So the arrow you must draw, go in the negative charge. So this one we call like charge that attract to each other. So this one center is a full with the electric field line lah, because they attract to each other. Okay, so then later we got one of the activity they can show about how about the movement of the electric field, because here we cannot see. So this is one of the the activities. Okay, you can see here the map of the electric field along the metal electrode. So they're using the diagram like this. Okay, so from here I explain the diagram first. One, they're using a semolina powder. Semolina powder is a light powder. Ringan, powder yang ringan. Okay, they disperse evenly the surface of the oil. That means the plate, metal plate here, they put one of the plate, normal plate. Excuse me. The pantry dish, they put the oil inside the pantry dish. Okay, number two, they got two metal plate. Two metal plate they join with the EHT. EHT here is a not power supply. There is an extra high tension power supply. So that means in normal using the power supply just 12 volt, they're not enough. They must high power. So from here they're using extra high tension. Okay, so from here they join with the positive and join with the negative. So these two plates now got one positive charge, another plate is a negative charge. Okay, then above inside the oil. Okay, now the semolina powder on the oil surface. Okay, they put the semolina powder on the oil. Then now when you just on the extra high tension, you see what happened for the semolina powder. The semolina powder, they will start to move it. They follow the charge to move it. So from here, they say they will align, they will susun. Okay, in the direction of the electric field, thus the map out the electric field line due to the action of the force of the electric field. So they will align, follow the shape of the electric field. That means later they will align like this. This one is all the line. They will align, they will susun. Okay, so from here you see the cooking oil is used. The question will ask here, this for this activity. Okay, the question will ask, why we using the oil? Why cannot using the water and other liquid? So your answer just got one. Why using the oil? First one is because the oil is a insulator. We don't want the charge, when just oil, all the charge go to water. Then how come the plate no charge already? So from here we want to make sure all the charge go to the plate. So the liquid you put inside the pantry dish, they must insulator. So we're using the oil. So the answer is here. Cooking oil is used because there's an insulator which does not conduct electricity. Okay, then therefore it able the high voltage to maintain the across the two electrode. So the high voltage can maintain to the plate. Okay, now I show you the activity diagram is how. Okay, this one is a experiment we need to do. Okay, positive is a red color, black one is a negative. They join with the power supply, extra high tension. So this one is a two plate. So later that means these two plates, they've got positive charge and a negative charge. Okay, this one is a pantry dish. Pantry dish, they need to add the oil. Okay, add the oil and also put the semolina powder. Okay, when I just start, okay, so this one is a semolina powder. You can see all the powder, they start to move. Can you see the center? Center, that means they align. They align at the center. Can you see the one straight line, one straight line, one straight line? So that means they susun by garisan lulus at the center. So this one is how they move. Okay, this one is drawing. Okay, this one you can see they move like the diagram lah. The center line you see. One by one they go to draw the line. This one the line is just like electric field line what we draw it. They're using the semolina to represent. Okay, so from here I show you this one is a demo. Okay, so because we cannot see the electric field line, so we're using the semolina to represent. Okay, now I need to draw the result. Okay, you can see here, this all is a pattern of the electric field. When I just put the single, this one is a single electrode. Okay, when I put two electrode, okay, what happened? Okay, just now we do the experiment is put the plate. This one is a plate. So now what we need to do is drawing. We need to draw the charge, how to produce. The arrow is how to go. Okay, so from here we got so many types here. First one we start with the single electrode first. Okay, first one, when you got one of the electrode positive charge, okay, another one is a negative charge. Okay, the next one we combine, we got two electrode, positive and positive. Okay, or another one is a positive and also the negative. How to draw? Okay, we separate. Okay, and the next one we using the plate. Positive charge and all is a negative plate. Okay, what happened? And the last one is using two plate, positive plate and also the negative plate. Okay, so from here we need to draw the electric field line. Okay, for the first one, remember again the arrow is from the positive they will up, for the negative they will in. So from here we start, we draw the four important four line. Okay, after that you go to add. So this one is a positive charge, all the field line. Okay, negative also same, the pattern is the same, different just the arrow is going. Okay, so this one is a negative charge. Okay, this all is an electric field. Then this one is an electric force, or you can say electric field line. Okay, next, when two electrons, this one is a dislike charge. Dislike charge means later they cannot attract each other. So if they cannot attract to each other, so the center must be empty. Center don't have any line. Okay, the first step, we draw the, at the side we draw the line first. Okay, so from here you cannot attract, so you must far away. Show there's a far away. Okay, how about this one? This one also far away. Okay, the next one also show they are far away. Okay, you want to draw how many is okay. It's up to you, just important, don't cross over. Okay, far away. Okay, now center is empty. Now we draw the arrow again out from the charge. This one positive, huh? So if you draw the negative, also same lah. The pattern is the same, just you want to draw the arrow is different. Okay, so this one is a dislike. Okay, now we draw the like charge. Okay, when two they are put together, then the charge is opposite. So this one is an attract. When they attract, the center they got line. So first one you draw the center line lah. You got the attract one. So from here they attract. Okay, they can create the line together. Okay, how about this one? This one we go there lah. You want to find your partner because you are attract. Okay, so from here you can draw more than one. Okay, I cannot cross so you see the pattern just like a spider. Okay, so from here positive out. Okay, out again, here out. Okay, how about the negative? Negative charge, they will go in. So they will go in, is go in. This go in. Okay, so this one is a dislike charge. They will attract to each other. Okay, so now we're going to see the plate. Okay, now we change. So one is an electrode, another is a plate. This one positive and negative, that means they will attract to each other. Okay, attract to each other means the line, the closer lah. Okay, this one to find, everything they want to find. Just like this lah, we don't have other direction. So all they want to find. So from here the line becomes this. Excuse me. Okay, so this one is okay, you want to draw more? Okay, this one is positive and also negative, they will attract each other. Okay, next, this one is what just now the activity they show. They're using two plates. Then they're using two plates. What happened for the center? Center sure cannot empty because you attract to each other. So from here the center we draw straight line. We draw the straight line because they just like the what just now the semolina how they align. Macam mana dia susun. So they align at the center. So at the center, because semolina you cannot see the arrow. Okay, but we know the charge must from the positive go to negative. Okay, not like this only. So you must see center they align. Okay, outside we also got. Okay, just now the semolina they also go outside, go to align. How they align? Curve. They curve to align. So they curve the align, the arrow should be the same. So remember when the exam they want you to draw, you not just draw the inside one. The outside, the curved one, you also need to draw. Okay, draw one enough already. No need to draw more. Okay, outside one, then the center you draw the line. After that, please label the arrow. Okay, from the positive go. Then if you see from negative, this one is another opposite direction. Okay, so this one is the pattern of the electric field line. Okay, when the question they want you to draw it. Okay. Then we got another experiment. Not experiment, they just got some activity. They want to find out what happened for the electric field of the charge. Okay, this one. Okay, you see the diagram. Okay, I'd like you to see clear. Oh, we got two plates. Okay, this one was using the EHT, also same extra high tension power supply. Okay, this one is joined with the positive charge lah, another one is joined with negative charge. Okay, after that center, they put one hanging by nylon thread, one of the ping pong ball. Okay, this one question they want to see what happened for the ping pong ball when the charge is on. Okay, the problem is they will ask you the question, why we using nylon thread? Why cannot using the metal? The metal thread you join about the ping pong ball and then you let the ping pong ball move lah. Why we cannot using the metal? Okay, anything about the metal we cannot use. Reason? Because the metal can conduct electricity. When the metal just conduct electricity, that means now the plate will reduce the charge. Okay, another way is the metal too heavy lah. Okay, maybe the ping pong ball cannot go to oscillate. Okay, number two, they will ask, why are you using the ball? Ping pong ball? Okay, ping pong ball here, we just not normal ping pong ball, you know. We need to coat by a little bit metal. Coat metal, that means it's easy to absorb the charge. Okay, ping pong ball, first one, mass. The mass less. When the mass less, they're easy to oscillate. So that means, I never say I put the tennis ball, is it? Tennis ball too heavy, how to oscillate? You attract how much, they also cannot move. So from here, we're using the lighter object, that's a ping pong ball. After that, we're using the nylon thread. Okay, nylon thread, the reason is, that's an insulator, do not conduct electricity. Using ping pong ball because the mass is less, okay, lighter, so they're easy to oscillate. Okay, so from here you see the experiment. The first one, they say the ping pong ball is coated with the metallic paint. Okay, metallic paint, that means they can easy to absorb the charge. Okay, number two, high voltage is switched on. High voltage is EHT, extra high tension. Okay, ping pong ball is coated the negative, we touch the negative plate and also release. So the first, when I on, the ping pong ball is never move one. It's a neutral. They got neutral charge, positive, negative also got. Okay, so you need to help the ping pong ball to touch either one of the plate first. Okay, so when they touch either one of the plate, okay, the situation will start. The ping pong ball, then we need to continue to explain what happened for the ping pong ball. Finally, the ping pong ball will oscillate between the plate. Okay, now I show you the diagram. Okay, this one is just now what we draw about the charge electric field line. Okay, so make sure you know how to draw. You need to practice. Okay, and this one is the setup. Okay, can you see? Okay, we're using the extra high tension. After that, we join positive and negative for two plate. Okay, this one is a ball, the ping pong ball. Okay, later they will oscillate between the two plate. Okay, later they will oscillate between the two plate. Okay, now we need to see how they will oscillate. You need to explain. They may be to come up for the process question format. They just want you to explain. Please explain how come the ping pong ball can oscillate between the two plates. Okay, so from here we're going to see the notes. Okay, now I draw first. Okay, this one is your positive plate. This one is your negative plate. Okay, the ping pong ball is here. Ping pong ball also got positive and also the negative. Okay, when starting there's a neutral. Okay, so from here the first step you must say oscillate. You must move. That's a number 3. The notes for number 3. The ping pong ball is touch the negative plate and release. So you move it to the negative plate first. Okay, and you remove. Okay, now you need to explain. When the ball, they go to touch to the negative plate, what happened? Okay, now you see the ping pong ball, they will oscillate between the two plates. So from here, this one, number 4, they're straightforward to say about the conclusion. What happened? They will oscillate. Then you need to explain why they will oscillate. Okay, number 5. When this one, they go to the negative plate, what happened? Okay, all the positive will lost. Agree? Because they go to neutralize with the electron. All the positive will go here. All the charge positive, they attract by the negative plate. Now what happened for the ping pong ball? The ping pong ball finish all the positive charge. That means now all inside is a negative. Okay? So if all inside is a negative plate and negative ball, what happened? They will repel. Excuse me. Okay, number 2, you're talking about neutralize. Neutralize. The ball will neutralize with the electron on the negative plate. Okay, then they will absorb all the negative charge. Okay, after that, number 3. When they attract all the negative charge, what happens again? They will repel. The shell will repel because you are negative, the plate also negative. Now when you repel, where they go? They must go to the positive plate. Okay? They must go to positive plate. Now when you go to positive plate, because your ore is a negative charge, you go to positive plate, okay, the positive plate must be welcome, you come here. Because I'm the positive, you are the negative, I want to attract you. So when you just come, then you want to repeat again. Okay, when you just go here, then neutralize again, no? The negative, they will neutralize with the positive charge. Okay, after that, the ping pong ball lost all the negative charge, you full with the positive charge, then you repel again, then you go to the negative plate. So this process, they will repeated oscillate for the ping pong ball until you are switch off the charge. Okay, you switch off the charge, that means they become neutral. Okay, they slowly damping, then finally no more. So this one is a process. So from here, I got explain all the thing is here. So when you write the process question, you refer the diagram, write 1, 2, 3, 4. Then after that, refer the diagram number, then you go to explain. Okay, the words like this, number 5. Because the ball touched the negative plate, it receives the negative charge. The ball is attracted by the positive plate. Okay, you go here, you receive negative plate, then you neutralize, then you attract by the positive plate. Okay, when the ball touches the positive plate, the charge is neutralized again. So, and immediately they receive the positive charge. So the ball will attract by the negative plate. After neutralize, then you got all positive, then attract again by the negative plate. So the last one, 7, the process is repeat, cause the ball oscillate. So this one is the answer. Okay, the rest, they ask the speed of the ball, how to increase. I want to make this one ball oscillate faster. Okay, we got 3 factors how to make the ball oscillate faster. First one, distance between 2 plates, these 2 plates. I make it closer. Okay, when the plate make it become closer, means the charge becomes stronger, is it? When the charge becomes strong, that means the ball will move faster. Okay, they don't need to waste so many charge left and right. So the distance closer, that means they're easy to move. Okay, number 2, the mass of the ball must be decreased. So that's why I say cannot using the tennis ball, but too heavy, cannot move what. Okay, number 3, you use the high tension. Why I call you using extra high tension? Because the voltage is too high. When the voltage high, that means you got enough charge. So this one is the 3 reasons how to make it become the oscillation become stronger. So this one is a factor. Okay, next. For this one situation, we take out the ping pong ball. We want to using the ping pong ball. Now I put the candle with the flame, I put at the center. So the diagram here. Okay, they just remove the ping pong ball but replace the candle with the flame. Okay, now they say a light candle is placed between the 2 metal plates. That means 2 metal plates still got charge, positive and negative. Okay, now the voltage supply switch on. You on your EHT. Okay, flame seen flattened. Okay, means like this. Okay, this one candle. Okay, normal candle like this lah. This one is a flame. Okay, now I got positive. I got negative. If I'm not yet on, the flame is go out. So that means when they just on, when I on already, okay, they say the flame become flattened. What means of flatten? Flatten means like this. Go down, flat already. Okay, number 2. Then, okay, number 2, they say voltage on, the flame flatten and spread out more to the negative plate. Okay, for the third notes, they got 2 questions. First, why flatten? Why the flame, when I just on the EHT, they become flattened? Number 2, they say, why they move more to the negative plate? That means later they flatten already. This part they will move more or go to negative plate. Okay, then we understood lah. You go to the negative plate, sure is a positive charge, right? Is it? This is a negative. And they ask why. Why then more will go there? Okay, so that means we got two questions. You need to answer. Okay, we see number 4 and number 5. Number 4, they answer the first question. Because the heat burning candle, they produce positive and negative ion. So that means when a candle, they got flame, inside the automatic, they got positive and also the negative ion. Why? Because they ionize with the A molecule. Surrounding, we got A molecule. I show you the diagram, you see it. Okay, this one. So from here they say what? The heat of the candle flame remove the electron from the A molecule around and therefore ionize the molecule. So from here you see the normal flame. The inside they got positive ion and also negative ion. Okay, this one is when the plate not yet on the charge. So you imagine when I on the plate, positive and negative charge, what happened? The flame sure be separate. Yes or no? Because the positive will go to the negative plate. Then the negative ion will go to find the positive plate. So after that, you find it, they will flatten. This one is flattened. Okay, I zoom, I let you see clear. Okay, flatten. Okay, then you see the big part will go to this plate. So that means this plate is a negative plate. Why the big part will go here? So first, I answer the question already. Why become flattened? So the flattened reason is the flame, they will ionize by the surrounding A molecule. Then they produce positive ion and negative ion. Okay, then they become flattened. Okay, the second question, this one. Why the big part, they will go to the negative plate? Okay, you can see clear. The big part is a positive ion, they go to negative plate, bigger part. The small part, they go to positive plate only. Okay, now we go to answer. Refer your notes also, they will answer there. Okay, the answer is number 4, number 5. Okay, number 4, because the heat burning candle produce positive and negative ion, so they become flattened. Okay, fine. The positive ion means this part. The positive ion which are heavier, they are more heavier. So they pull towards the negative plate with the larger force. So this part, you are more heavier compared to the electron. So they're using larger force to pull you to go there. When the larger force pull you to go there, so you find it, they will occupy larger portion of the positive charge. So the larger part of the flame, they will pull to the negative plate. So this one is the answer. So if the question asks why the flame, the bigger part or the positive charge will go there, so your answer just say the positive ion is more heavier. So then they say what? The larger force occupied. Okay, large force occupied, then the large proportion of the flame will pull to the negative plate. Okay, heavier. Positive charge is more heavier and pull more force. The more force you put it, go to the negative plate. So this 2 is the answer. Okay, so this one got one question. Nylon. Why using nylon? Because there's a insulator, do not conduct electricity. Okay, number 2 is candle. Okay, why become flattened? When I just charge, when the plate just on, the EHT just on. Okay, so your reason is because the flame will ionize A molecule, then produce a positive and negative charge. So the positive will attract to the negative plate, the negative will attract to the positive plate, so they become flattened. Okay, this one is why the bigger portion will go to the negative plate. So the bigger portion go to the negative plate, this all is a positive ion. Positive ion is more heavier. So larger force to pull it, go to the negative plate. So this one is a activity question they will ask, electric charge. Okay, so this all is what we learn about the 2.1. There's an electric field and also the current. Okay, then we need to know the next one is a tutorial question. We need to do is 2.1 tutorial question. Okay, all the objective question you try first. Okay, the next lesson I will show you the answer for the objective and also structural question. Okay.